Hello, welcome to next session. In this session, we will solve GATE 2016 production and industrial engineering. Okay. First of all, 1 mark question. The eigenvalue of matrix 0, 1, minus 1, 0 are option A, iota and minus iota, option B, 1 and minus 1, option C, 0 and 1, option D, 0 and minus 1. So to find out eigenvalue, subtract the lambda from diagonal elements and put the matrix equal to 0 and then solve the matrix, and by solving this matrix we get minus lambda into lambda square plus 1, okay, and lambda is the 2 plus minus 1. So answer is your B answer. Okay. Next, the number of solutions of simultaneous algebraic equation y is equal to 3x plus 3 and y is equal to 3x plus 5 is option A 0, option B 1, option C 2, option D infinite. So this is the linear equation. Okay. So uh, the two equations are y is equal to 3x plus 3 and y is equal to 3x plus 5. So comparing with this, a1y plus b1x sorry is equal to b1x plus c1 and a2y is equal to b2x plus c2. So for no solution, a1 by a2 should be equal to b1 by b2 and should not be equal to c1 by c2. So here this condition is satisfied, so it has zero, no solution. So number of solutions are zero. Okay. Next, at x is equal to 0, the function fx modulus sine 2 pi x divided by n, uh, and x is varying from minus infinity to infinity and L is greater than 0. Is continuous and differentiable, not continuous and not differentiable, not continuous but differential, continuous but not differential. So this is your fx. Okay, if we drop a fx, because it is modulus, so it will be positive for each and every value of x. Okay, and when we put x greater than 1, then we get this shape, and then put x less than 1, then we get this shape. Okay, so in all the shapes, fx is positive because of this modulus. Okay, and at x is equal to 0, and this graph can be drawn by without lifting any pen. So this is a continuous function. Okay, okay, everywhere. Okay, but at x is equal to 0, there are two separate curves. Uh, this curve, if it is continuous, if it should be like that, okay, but it is taking and because it is taking different shape. Okay, here and here it is different. So the function is not differentiable at x is equal to 0. So when the curve can be drawn without lifting a pen, then it is continuous. And when the curve taking its when the curve are changing its nature, at that point the function is not differentiable. So answer is yes. It is continuous but not differentiable. So answer is B. Next. For the two functions fxy is equal to x cube minus 3xy square and gxy is equal to 3x square y minus y cube. Which one of the following option is correct? Curly option A. Curly f by curly x is equal to curly g by curly x. B. Curly f by curly x is equal to minus curly g by curly y. C. Curly f by curly y is equal to minus curly g by curly x. D. Curly f by curly y is equal to curly g by curly x. Okay. So fxy is this and gxy is this. Okay. Now finding out curly f by curly x, that is 3x square minus 3y square, and curly f by, that is your minus 6yx. Okay. And curly g by curly x is your 6xy. Okay, and curly g by curly y is your 3x square minus 3y square. Okay. So this is curly f. Now from this we can see that curly f by curly x is equal to curly f by curly x is equal to curly g by curly y, but it is not in the option. And curly f by curly y is equal to minus curly g by curly x. So this is in the option, that is option C. Okay. So answer is your C. Next, the function fz is equal to z square plus 1 divided by z square plus 4 is singular at option A, z is equal to plus minus 2, B, Z is equal to plus minus 1, C, Z is equal to plus minus iota, and Z is equal to plus minus 2 iota. Okay. For singularity, the singularity of the function is defined as of a complex variable is the point variable is not analytic. Okay. So when this quantity is zero, when the denominator is zero, then the function is not analytic. Okay. So fz can be written as z square plus 1 divided by f z plus 2 iota minus sorry, multiply z by 2 iota. So if this quantity is zero, when this quantity is zero, then function is not analytic. So from this, by putting this equal to 0, we get z is equal to plus minus 2 iota. Answer is the answer. Next, a pair of coins is tossed n times. The probability that the head does not turn up in any one any of the tosses is option A 1 by 2 n minus n, B 1 by 2 1 minus 1 by 2 n minus n, okay, and C 1 by 2 n, D 1 minus 1 by 2 n. Okay, so the probability of coming head in one toss is 1 by 2, and not coming head is also 1 by 2. Okay. And in n tosses, the probability of not coming head is what? 1 by 2 multiplied by n times. Okay. So it will be answer is what? 1 by 2 and option C. Okay. This is multiplicative rule of probability. Okay. Next, a normal random variable x has the following probability density function: fx x 1 by root 8 pi e minus x minus 1 square by I bracket close, and x is equal to minus infinity to plus infinity. Then f x x dx limits are 1 to infinity. Option A 0, B 1 by 2, C 1 minus 1 by e, D 1. Okay. So here the fx is given by this. Okay. Now if we put x minus 1 is equal to z, then we have if we put fx x is equal to x minus 1 is equal to z, then x is varying from minus infinity to infinity, as x is varying from minus infinity to infinity. So z will also vary from minus infinity to infinity. Okay. So and the equation will come f in terms of fz. Okay, it will be in terms of z. We can write it as fzz. Okay, 1 by root 8 pi e uh, minus z square by 8. Okay, so this is an exponential function. Okay, with uh, with z varying from minus infinity to infinity. Okay, if we find out the density of this, this is a probability density. Okay, and this is a symmetric function about z is equal to 0 to minus infinity and z is equal to 0 to plus infinity. Okay, if we integrate, if we multiply it by dz and integrate it, okay, as it is a probability function, so the total summation of the probability should be 1, because total probability cannot be more than 1. So as z is vary from minus infinity to infinity, so and so this should be equal to fz, dz should be equal to 1. Okay. Okay. It means and it is symmetric about z is equal to 0, because z is varying from minus infinity to 0, minus infinity to infinity. So 0 x 0 to infinity fz dz should be equal to 1 by 2. Okay. And when z is 0, x is your 1, and when z is infinity, x is your infinity. So it is, so answer is your B, option 2. Okay, 1 by 2 answer. Next, the elastic modulus of a rigid perfectly plastic body is option A 0, B 1, C 100, D infinite. Okay. The elastic modulus of a rigid plastic body, as a plastic body will not have any elastic strain. Okay, so for perfectly plastic body, the strain is 0. Okay, and when the strain is 0, then the stress by strain is your infinity, and that is modulus elastic answer is infinity. Answer is very okay. Next, consider the following statements. Okay, P, hardness is the resistance of material to indentation. Q elastic modulus is the measure of ductility. R deflection depends upon stiffness. S the total area under the stress strain curve is a measure of resilience. Okay. So hardness is the resistance of material to humidity. That is correct. Okay. Elastic modulus is not the measure of ductility, but the stress strain curve area uh, is the measure of ductility. Okay. The area after elastic limit and up to fracture is the measure of ductility. Okay. So deflection depends upon stiffness, and stiffness we know that load and friction resistance. That is correct. This is incorrect. The total area under the stress strain curve is the measure of toughness. Okay. So answer is your P and R. So it is option C. Okay. Next, a beam is subjected to an inclined concentrated load as shown in the figure below. Neglect the weight of the beam. So this is beam, this is load, this is the support. Okay, the correct three body diagram of the beam is, so this is the beam. Okay, these are the beam. Okay, and here there is inclined load. Okay, as there is only load on the beam, so the support will provide reaction, not the moment. Okay, so due to vertical load here, the vertical reaction will be there. Okay, and due to horizontal load here, the horizontal reaction is there, and uh, this support provide both vertical and horizontal reaction. So answer is B. So this is roller sport. This cannot provide rental sport. So answer is B. Okay. Okay. Sport provide only resisting movement, not the movement. Resisting reaction, not the movement. Roller sport does not provide any horizontal sport. And third is horizontal component of load will be supported by the horizontal reaction. Okay. So these are the three main factors. Okay. Next, consider a circular cam with a flat face follower as shown in the figure below. The cam is rotated in the plane of paper about point P, laying 5 mm away from its center. The radius of the cam is 20 mm. The distance in mm between the highest and lowest position of the flat place follower is. So this is your cam, and this is your follower. Okay, and this distance is 5 mm. Okay, so options are A 10, A5, B10, C40, and D45. Okay. So this is the topmost position of the follower. Okay, and at this topmost position, this uh, center will be vertically above this uh, point of rotation. Okay, and this will be 20. This is as the radius is your 20 mm. Radius is 20 mm. So this is your 20 mm. Okay, so the total topmost position will be at 25 mm, and when the when this part comes at the bottom, then this will be 25 mm. This is 15 mm. Okay, so the here the displacement of follower will be 25 mm. Here the displacement of follower is 5 mm. So this is here the 20, 25 mm. Okay, and here it is 50 mm. Okay, because total is your 40 mm. So this will be your 50 mm. Okay. So this is your 15 mm. Total is your 40 mm as radius is your 25 mm. So 20 mm. So total is your 40 mm. This is your 15 mm. And this is your 25 mm. So the topmost position will be 25 mm from the center of rotation. Okay. And the bottommost position will be 15 mm from the center of rotation. Okay. So answer the difference is your 25 minus 15. That is 10. So answer is your B. Next. A vertical cylindrical tank of 1 meter diameter is filled with water up to a height 5 meters from its bottom. The top surface of the water is exposed to atmosphere. A hole of 5 mm square area forms at the bottom of the tank. Consider the coefficient of discharge of the hole to be unity and acceleration due to gravity to be 10 meter per second square. The rate of leakage of water in meter per minute through the hole from the tank to the atmosphere under the given condition is. So this is your tank. The height is 5 meters and this area is your 5 mm square. Okay, and the velocity will be your 2gh. So h is here is 5 meters and g 10. So it is 10. Suppose we are taking it to it is given. Suppose g is, we should take as 10. Okay. So the velocity will be your now 10 meter per second. Okay, and area is given. So if we multiply area with velocity, then we'll get the volume flow rate. Okay, this will be in mm cube per minute. So this should be sorry, this is velocity. Okay, so this is velocity. Sorry, so velocity is your 10 into 1000 into 60 in mm per minute. This is in mm per second. Okay, so now area of this hole is 5 mm square. So discharge is your B into A. So multiplied by 5. Okay, and it will be in mm cube per minute. Okay, or we can change into it into centimeter cube by dividing it 10 to the power 3. Okay, and so now discharge is your centimeter cube per minute, and 1 meter cube is equal to 1 by 1000 liter. Okay, so now again dividing it by 1000, we get 3 liters per minute. So answer is your 3 liters per minute. So answer is 3 liters per minute. Optionless question. So answer is your 3 liters. Next, the figure below shows an air standard diesel cycle in the PV diagram. The cutoff ratio is given by. So this is your cutoff ratio V3 by V2. This is the answer. C is the answer. So compression ratio is given by V2. And cutoff ratio is V2. And V for the V3 is the expansion ratio. Yes. The ratio of press force required to punch a square hole of 30 mm side in a 1 mm thick aluminum sheet to that needed to punch a square hole of 60 mm wide and 2 mm thick aluminum sheet. Okay. Now here there is square hole that is 30 mm. First in first condition the area of the sphere is sorry the sphere hole is of 3 mm 30 mm side. Okay, so in the shear the area is parallel to the load applied. Okay, and uh, so the perimeter of the hole is your 4 into 30 because each side is your 30. Okay, and so the area to punch the hole is your perimeter into thickness. Okay, so this is the area of the area where the punching need to be performed. Okay, and punching the shear stress is the main cause of main cause of failure or main cause of what can say, making a hole. Okay, so shear stress is required to cause a punching of hole. Okay, so this is the punching force. P1 is the punching force, and punching force is equal to shear stress into area. Okay, so P1 is equal to tau into 120. Okay, this is your 120. This is the first case, and in the second case, the whole side, the east side is your 60 mm, and thickness is your 2 mm. Okay, so the area will be your 4 into 60 into 2. Okay, so the as the material is same. Okay, so tau is also same. Tau to cause failure of or to cause hole is same. Okay, So tau is same, so this is your force tau, and this is your force P2. Now the ratio of this first force to second force is your 120 by 480. This is 1 by 4, that is 125. Answer is your 20. Next, which one of the following is a natural polymer? Option A, cellulose. Option B, nylon. Option C, polyester. Option D, polyvinyl chloride. Option A, cellulose is the natural polymer, and other natural polymers are silk, wool, DNA, and thermoplastic, thermoset, elastomers, synthetic fiber are your artificial polymers. Next, in a powder metallurgy sintering of the component, option A increases density and reduces ductility, B increases porosity and reduces density, C increases density and reduces porosity, D increases porosity and reduces brittleness. So answer is yours C. The sintering is the process of compacting the powder. Okay, so it increases density and reduces porosity, and the powder has been compacted by using heat or pressure, okay, without melting it. Okay, so answer is C. Next, a single point right-handed turning tool is used for a straight turning. The speed is 0.25 mm per revolution. The uncut chip thickness is found to be 0.25 mm. The inclination angle of the main cutting edge is 10 degrees. The back rack angle is degrees. Okay. So we know that the thickness and feed, there is relationship between thickness and feed. Okay. So uncut thickness is equal to T1 and F is feed. Okay. Then this is the relationship between uncut thickness and feed and your side cutting edge angle. Okay. Here the side cutting edge angle as single point of and if you use your for straight turning also. So okay, as a single point particular is used for straight turning. Okay. As it is used for straight turning, okay, so the side cutting edge angle is your this is your side cutting edge angle. So this is your straight, okay. This is straight, so the anchor thickness is equal to so side cutting angle is your 0. Okay. So cos 0 is your 1. So T1 will be equal to F. Okay. So whatever field we give, that will be the uncut thickness. Okay. So when this side cutting edge angle is equal to 0, okay, and thickness is your equal to feet, then then this inclination angle of the main cutting edge is the back rack angle. So this is your inclination of the main cutting edge angle, and this is this then the back rack angle. Back rack angle is given by this. Okay, there is no inclination perpendicular to the surface. So answer is this. So answer is 10. Okay. Next, consider the following statement. Option, sorry, P electrolyte is used for used in electrochemical machining. Q electrolyte is used in electrical discharge machining. R abrasive slurry is used in ultrasonic machining. S the abrasive slurry is used in abrasive gas machining. So the electrolyte we use in in electrochemical machining, that is correct. Okay, but it is not used in electrodischarge machining. Okay, and abrasive slurry is the mixture of abrasive particle and water. Okay, and that is used in ultrasonic machining. And whereas only abrasive particles are used in abrasive jet machining, no water is used in abrasive jet machining. So answer is your P and R. So option A is the readout is electrode used for in electrochemical machining. The brushes are used in ultrasonic machining. Electric discharge machining uses the electric fluid, which serves as the two process. So it is detect a semiconductor between the electrode and workpiece to facilitate the stable and controlled spark gap ionization condition. It also acts as a flushing agent to wash and remove the eroded uh, debris from the sparkle. Okay, this is not used as electrolyte. Okay, so and option fourth is abrasives are used in abrasive machining in air or in CO2, but abrasive slurry, that is mixture of abrasive and water, is not used in abrasive jet machining. Okay, next, the limits of a shaft designed as 100 H5 are 100.000 mm and 100.014 mm. Similarly, the limit of a shaft designed as 100 H8 are 100.000 mm and 100.055 mm. If the shaft is designed as 100x6, the fundamental deviation in micrometer for the same is option A minus 22, B 0, option C 22, and option D 24. As we can see that the minimum size of shaft is just 100, okay, 100.00, and this is basic size. Okay. And minimum size of hole, and here the minimum size for the second shaft is just 100. Okay, similarly shaft. Okay, so the basic size is both for same. Okay, so and if the shaft is designed as 100 the fundamental deviation, so the fundamental deviation is related from the basic size. So the basic size will remain same in all the cases. Okay, so answer is 0. Okay. The fundamental deviation is close to the basic size. In all the cases, the lower limit is your 100.00. So the fundamental deviation is 0. Okay, so this is your basic size. Okay, and the basic size is same. Okay, okay. Next, consider the following statement. Computer-aided process planning takes input from the material requirement MRP. Production flow analysis helps in work cell formation. Our group technology takes input from choice of manufacturing or cutting parameters. Among the above statements, the correct one is P only, uh, the Q and R only, the P and R only, and Q only. Okay, so answer is Q only. The group technology takes input from the choice of manufacturing or cutting. Next, the roughness profile of a surface is depicted below. The profile height is this, okay, 2 micrometers. The center line is here 5. Okay. The surface roughness parameter in RA in micrometer is the surface roughness parameter is determined by the peaks and valleys in the height direction. Okay. Here the peak is your 2 micrometer and valley is your also 2 micrometer. So the roughness surface roughness parameter is your 2 micrometer. Okay. Next, the facility layout technique that uses REL relation, REL chart is that is a theory based question you have to remember this to answer is it. D. The facility layout technique uses automated layout design program, automated layout design program, which is used to evaluate relationship between two layouts. Next, for a random variable x, let x bar be the sample average. The sample size is n. The mean and standard deviation of x are mu and sigma, respectively. The standard deviation of x bar is option A, n sigma, B, sigma, C, sigma by n, d sigma by root n. So the standard deviation is in x bar, that is sigma by root n. Okay. Just the mean of standard deviation. The x, if standard deviation of the x is your sigma, then the standard deviation of x bar is your sigma by root n. Okay. So the lower control limit is your x double bar minus m sigma by root n, and upper control limit is this. Okay. So answer is your uh, the answer. Okay. Derivation. Next, ST and MT denote the standard time and the normal time respectively to complete a job. Allowance LL into ST, where LL is between 0 to 1. Which one of the following relationship is correct? Option A, ST is equal to NT by 1 minus LL. B, ST is equal to NT bracket 1 plus LL. C, ST is equal to NT by 1 plus LL. D, ST is equal to NT bracket 1 minus LL. Okay. So standard time is your, the standard time is your normal time plus long time. Okay. And normal time is written by NT, national time is your by ST. And allowances are this LL and ST. Okay. So taking this term here, so we can get ST is equal to NT minus NT by 1 minus LL. So answer is your next. The throughput rate of production system is 20 units per hour. The average flow time is 30 minutes and the cycle time is 3 minutes. The average inventory in units in the system is option A 1.5, B 9, C 10, D 11.33. Okay. So the what is throughput? Okay, throughput means the amount of material passing through a system. Okay, and that is given as 20 units. Okay, per hour. Okay, in a 1 hour, the 20 units of 20 units are passing through the system. Okay, and but the average flow time is your 30 minutes. Okay, average flow time is your 30 minutes. Okay, so inventory in 1 hour is 20 units. Inventory in your in so in 30 minutes is just 10 minutes. So average inventory in the system is just 10 minutes. Answer is just C. Next, the range of values of k for which the function fx is equal to bracket k square minus 4x square plus 6x cube plus 8x4 has a local maxima at point x is equal to 0 is. So these are the options. K is equal to k less than minus 2 or k is greater than 2. B, k less than equal to minus 2 and k is greater than equal to 2. K is minus 2 to 2 and k is more than minus 2 and less than minus 2. K is equal to and more than minus 2 and less than equal to 2. Okay. So fx is your this quantity. Okay, now differentiate it. We have to get the maximum function. Okay, and so differentiating it. Okay, so it will be 2x. It will be 18x square. It will be 32x cube. Okay, so so differentiating again. Okay, that is so this will be 2. This will be 30x, 36x. Okay, and this will be your 96. Okay. Now if we uh, now we have to find it is given that there exists a local maxima at x is equal to 0. So now putting it f dash putting the x is equal to 0 and then finding f double dash x. Okay. Okay. So this for x to x is equal to 0 to represent maximum, this quantity should be negative. Okay. So it means f double x should be negative. Okay. Or k square minus 4 into 2 should be negative. Okay. Or which is possible when this quantity is less than 4. Okay. So this will be to answer is C. It will be possible when k is greater than minus 2 and less than 2. So answer is your C. Next, limit x tends to 0, e raised to power 5x minus 1 by x whole square is equal to. So if we put x is equal to 0, we get this is here 1 minus 1 0 and this is 0. So it is 0 by 0 form. Okay. So using L hospital rule. So what is L hospital rule? Uh, we have to differentiate it the above term and we have to differentiate the uh, this bottom term, okay, and it create it to the original one. Okay, so this is your f limit x into 0 fx divided by gx, and it should be equal to limit x into 0 f dash x by g dash x. Okay, so this is your L hospital. Now, if we put now if we differentiate it, the 2 e5x minus 1, okay, and this is the differentiation and differentiation 5. Now differentiation of this inner term 5 e 5x and its differentiation is positive x here. This is 2x. Okay. Now 5 2 and 2 we can throw 5 e 10x minus the e 5x by x. So again it is 0 by 0 form. Now again using L hospital rule. So limit x into 0. Then differentiating it, sorry, this 5 will remain here. And differentiating it, this will be 10 e 10x. And this will be 5 e 5x. Okay. So putting x is equal to 0. This will be 10 minus 5. So this will be 20. So answer is the 25. Next. To solve the equation 2x, 2 sin x is equal to x by Newton-Raphson method, the initial guess was chosen to be x is equal to 2.0. Okay. Consider x in radian only. The value of x in radian obtained after one iteration will be closest to. So this is your minus 8.101. Okay. This is 1.901. This is 2.0999 and this is 12.10. So this now here fx will take this x here, okay, and then take it as fx. Okay, so fx is your sin x minus x now, and initially it is x naught is your 2. Okay, so fx naught putting the value of x as 2. So this will be in radian, 2 in radian. So, calculated, so it will be minus 1.814. Okay, so now, if we differentiate it f dash x, okay, then it will be 2 cos x minus 1. Okay, so f dash x 0 is again, you can find out by putting x to 2. Okay, so this is your f dash x naught. Now, according to Newton-Raphson method, the next term is xn plus 1 is equal to xn minus fxn minus f dash xn, and xn is here 0. Okay, and fx do not we have this, and f dash x naught we have this. To put this value and x naught we have this too. Okay, so we can get the next term, that is x is equal to 1. If putting this value, we can get this. So answer is 1.9009 or 1.901, option B in the next. In linear gas tungsten arc welding of two plates of same thickness, so of same material, the peak parameter T in Kelvin is given as T is equal to C1 Q by alpha, where Q is the heat input per unit length in joules per meter of the weld, alpha is the thermal diffusivity in meter square per second, and the plate material, and C1 is a constant independent of process parameter and material type. Two welding cases are given below. Case 1, V is equal to 15 volts, I is equal to 200 ampere, V velocity V is equal to 5 mm per second, and K is equal to 150 watt per meter per second, rho is equal to 300 kilogram per meter cube, C is equal to 900 kilogram per kilogram per degree. Case 2, V is equal to 15 volt, I is equal to 300 ampere, V is equal to 10 minutes per second, K is equal to 50 watt per meter Kelvin, rho is equal to 8,000 kilogram per meter cube, and C is equal to 450 joule per kilogram per meter. Where V is the welding voltage, I is the welding current, B is the welding speed, K, rho, and C are referred to thermal conductivity, density, and specific heat of the plate of material respectively. Consider that the electrical energy is completely converted into thermal energy. All other conditions remain same. The ratio of peak temperature in case 1 to that in case 2 is option A 1/3, option B 1/2, option C is 1, option D. Okay. Now, the general equation is given as T is equal to C1 by C1 Q by alpha. Okay. Where C1 is constant and Q is heat input per meter cube. Okay. And alpha is thermal. Okay. In the first case, the voltage is 15 volt and current is of 2000 amperes or 200 amperes and velocity is of 500. Okay. So, this is your V into I is your uh, V into I is your heat input per second. Okay, and if you divide it by this V, then Q we get Q is heat input per unit length. Okay, so we get heat input per unit length. Okay, this Q is just heat input per unit length. So this is VI is heat input per second and V is in meter per second. So we divide it by V, then we get heat input per meter length. Okay, okay. So this is your Q. Now other quantities are K is your 150 and rho is your 3000 and C is your 900. Okay, and we know the thermal diffusion is K by rho C. So now putting the value of K and the rho C, we have alpha. So in this equation we have in this equation we have Q and we have alpha. So we can calculate T1. Okay, so this is your T1. Okay. Similarly, for the second plate, we can calculate B into I divided by B into I divided by that small v q and then find out alpha because their respective values are given. V is given, I is given, V small v is given, K is given, rho is given, and C is given for the second plate also. Okay, so if we now for the second plate the equation is like this. Okay, now if we divide these two, we get answer T1 by T2 is equal to 1 by. Okay. Next, a bar of rectangular cross-section area of 50 mm square is pulled from both sides by equal force of 100 Newton as shown in the figure below. The shear stress in MPa along the plane making an angle 45 degree with the axis shown as a dashed line in the figure is. So this is your bar. This is acted upon by 100 Newton force, and this is your inclination plane angle. Okay, and as it is the case of uniaxial stress or uniaxial force, so and this represents the maximum. This force divided by area represents maximum normal stress. Okay, and we know that the shear stress is always at a 45 degree to the maximum normal stress or maximum stress. Okay, this can also be shown by this more circle here when the here area is 50 mm square, force is 100 Newton, so stress is your 2 MPa. So this can be represented as 2 MPa, 2 MPa, and this is your inclination angle. Okay, now if we draw a small circle, then this OA will be represented will represent 2 MPa, and in this plane there is no shear stress, so this point will be 0. And so this is the center, this will draw a circle, then this is more circle, and this will represent plane BD. Okay, this is plane BD, and plane BD, and also it will represent maximum shear stress. Okay, and as this quantity OA is a 2, so and this is diameter, and this is radius, so this is 1 MPa, so answer is 1 MPa. Okay. So we'll solve remaining question in the next video. Thank you.